Hello and welcome to Ms. Ma's Advanced Functions class. This is 2.4, using rates of change to create a graphical model. Okay, before we talk about that, we're just going to talk about displacement versus distance and speed versus velocity. If you're taking physics right now or have taken physics, then you probably know the difference already. Distance is just the actual number, how far are you from a thing. Displacement has to do also with directionality. So in what direction is it? Is it in front or is it behind? If it's in front, it'd be positive, and behind it would be negative. And then how far is it as well? So positive or negative distance away from a person or thing or whatever. Speed versus velocity is basically the same principle. Speed is just the number part, the scalar part, and velocity has to do with directionality. So what is the direction that that person is going? Are they going forwards or are they going backwards? So that is the difference between displacement versus distance and speed versus velocity. Just another reminder, you have to know that speed is equal to distance over time, and that's just a really important formula to know. And then we're just going to quickly review the increasing versus the decreasing line. Basically, when we're increasing, we have a positive slope, and we're going upwards. And as we're decreasing, we're going downwards, so we have a negative slope. This is true for lines, and I'm going to use the terms positive and negative in relation to curves, although they're not really quite accurate. But as we're doing the increase and decreasing, it's really important to remember that you're always going from left to right, okay? So whenever you're thinking about increasing and decreasing intervals, then you want to go from left to right. Okay, so here are some new terms for you. Increasingly increasing. So this increasing means that I have a positive slope. I'm going upwards as I go to the left. And this increasingly part means that I'm getting steeper as I go upwards. So you can see with this line that if I was climbing it, I would have a more and more difficult time climbing because the slope is getting steeper and steeper and steeper. And the slope of the tangent is getting greater and greater and greater in the positive. Okay, an increasingly decreasing curve, it means that it's going downwards. You can see as I go to the left, this is going down, and it's getting more and more negative. It's getting steeper and steeper. So that increasingly part just means that you're getting steeper in whatever direction, and then the increasing or decreasing shows you which way are you going to go. Are you going to go up or are you going to go down? Then we have decreasingly increasing and decreasingly decreasing. Decreasingly increasing means we are still going up, but as you're climbing, it becomes easier and easier to climb it. So we're going up, but it gets less steep. And decreasingly decreasing, we're going downwards. This is like a kiddie slide that kind of lets you off at the end so you don't like fly off the end and some sort of horrible, tragic playground accident occurs. So decreasingly, less steep, decreasing, going downwards. So we can use these to graph very complex relationships. This is going to be a simpler one for my example, but you'll have some difficult ones in your textbook. So this is a bottle, just a standard water bottle, and if you've ever filled up one of these water bottles, you'll know that once you get to about this point, suddenly all the water pours out the top and it fills up really quickly. So you're going along really slowly and steadily, and then suddenly it all just like squirts you. And that's really annoying. Well, that's because we're having the same volume go into the bottle, but because the base has suddenly become smaller and smaller, it has to compensate by going up more quickly. So we often will ask you to draw the graph of this, of the height over time as this bottle is getting filled up, or maybe it's getting emptied or something like that. So what would the height over time be? So if I'm filling this up with a volume and that volume is steady, then this part is going to be very steady, so it's going to be a line. Okay. And it's a nice shallow line because it goes very slowly, and then as we get smaller and smaller, we're going to be increasing still because we still have volume, but it's increasingly increasing because it just like fills up very suddenly. So that looks like this, right? And then when we hit the top of the height, then it's going to be flattened out because it'll be full. So that's what the height versus time, or time versus height graph would look like. You're going to have lots more to practice. Thanks for watching and have a good night.